All right, we're starting this morning with 2-1, the first lesson of chapter 2, and the lesson is called Integers and Absolute Value. So we're going to actually start with integers first, and I drew a number line here that in the center is 0, then we have a tick mark for 1, 2, 3, 4. The arrowhead shows me what? What's that telling me? That, yes ma'am? It keeps going on forever in the positive direction. And then I have these blanks here, but I have tick marks with an arrow. With the arrows telling me it's going infinitely, Tristan? In the negative direction. And I'm confused here, so we're going to fill in those blanks in just a bit. Let's look at a pattern. Let's just do some subtraction. And we'll do this actually later in this chapter. Yeah, come on in. We'll do this later in this chapter, and we'll kind of see how addition and subtraction relate. Or what's 5 minus 1? 4. What's 5? You can just put it anywhere. 5 minus 2? 3. 5 minus 3? 2. 5 minus 4? 1. 5 minus 5? 0. You guys okay with those so far? But then I could keep subtracting, and I get confused with my answer here. If you guys want to kind of follow me. 5 minus 6 would be what? Negative 1. Oh. Does anyone see the pattern of my differences? What's the pattern that I'm seeing here? As I subtract 1 extra, what happens to the differences? It goes down 1. Okay. So 4 goes to 3. Okay, I get that. Then 2, then 1, then 0. Wait. Are you telling me that negative 1 is less than 0? Yes, that's exactly what you're telling me through the subtraction and through the pattern. So here, what's the first number to the left of 0? Negative 1. What would be next? Negative 3, negative 4, and then we said it goes infinitely into the negative direction, or infinitely to the left. So I want to classify these numbers right here from 0, so after 0, the number right after 0, there you go, and into that direction to the right, we call these positive. So can I define positive this way? Positive numbers are all the numbers that are greater than 0. Is that okay to say? Yes. All the numbers that are greater than 0 are positive. You okay with that? The number line shows it. Here, we kind of drew it out. So somebody tell me, how would I define all these numbers with these negative signs? Like, how would I describe them? And then how do I classify them in a sentence? John?
We classify them as like negative.
Okay, they're negatives.
For all the numbers less than 0.
Okay, there you go. Negatives are the numbers less than 0. Okay? Negatives are less than 0. So that's good to know. So we have positives, we have negatives, and I want you to get this down, guys. The number line, the pattern that's being shown, okay, you go 4, 3, 2, 1, 0. Please go in the correct direction. Negative 1, negative 2, negative 3, negative 4, so on and so forth. Okay, so can I ask a question, see if you guys are thinking? Ready? Which number is bigger, 1 or 4? Which number is bigger? Yes, ma'am. 4. Good. Which number is bigger, 0 or 2? 2. No problem, right? All right, listen to my questions. Which number is smaller, negative 1 or positive 1?
Negative 1.
So negative 1 is smaller than positive 1. Okay, I get that. All right, ready? Which one's smaller, negative 4 or 2? Negative 4 or positive 2, which one's smaller? Negative 4 or positive 2? Which one is smaller? Bella?
Negative 4.
Negative, wait, I thought 4 is bigger than 2.
There's negative 4.
Oh, did you hear how I stated that? Is 4 bigger than 2?
Yeah.
But is negative 4 bigger than positive 2? No? All right, can somebody tell me how to use the number line to determine which number is bigger than the other? So negative 4 and positive 2. How can you kind of describe that with the number line? Good. The further you go to the left, the smaller you get. The further you go to the right, the bigger you get. And that works with the positives and the negatives. Okay, good. All right. And then this lesson is called Integers and Absolute Value. And what's the title of the chapter? Do you guys remember? Someone read it for me. Exploring integers. You think integers are important?
Yes.
Okay, what is an integer though?
I know what it is.
You know what it is? Go ahead.
It's a number that's on that line.
Okay, a number that's on that line. Good. How would you describe all the integers?
They all have value.
They all have value. That's good. Jensen? Say that they're all.
They can all add to each other?
Okay, they could, but there are other numbers that also can do that. What's an integer, or what are the integers? This is super important. And you know what, guys? Let me give you a hint. It's in the book. Okay, yes. Michael.
Isn't it one that is like when it has an opposite?
It has a big part of it is opposite. Yeah.
It's a point on the number line.
It is a point on number line, but there could be other points on the number line that are not integers. Bella?
The whole number and their opposite.
Oh, where'd you look for that, honestly? At the back? Okay, so read that again for me.
The whole number and their opposite.
All the whole numbers, so this is something you need to get, all the whole numbers and their opposites. All the whole numbers and their opposites. Okay, and that's a very important definition because we do use integers a lot, but we also use other numbers rather than the integers at times. Okay, does anyone know what the whole numbers are? Ooh, that's a deep question. Yes, ma'am?
Maybe like all the positive numbers?
Okay, it's all these positive numbers. Okay, ready? When I teach my son, Ezra, and Titus, and whatever other children we have, but when I teach them, I don't even know. Okay, anyway, I teach our children, I say, all right, I'm going to teach you these numbers first. Which numbers do you think I'm going to teach them first? What numbers do you think? 1/2, 0.79. I mean, what should I give them?
Like 1 through 10.
1 through 10. Why? Because those are examples of counting numbers. Have you heard of counting numbers? Natural numbers. Okay, when I count you guys, I count starting with the number 1. 1, 2, 3, 4, 5, 6. And I'm actually doing that with him, and it's cool. He says 1, 2. I'm like, yes, he knows how to count the 2. That's awesome. I don't start counting -5, -4, -3. That's not how we naturally count. So the numbers 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to infinity are called the natural numbers. Does that make sense? Natural numbers? Okay. Whole numbers. Whole numbers are almost the exact same as the natural numbers, except they have the number. What's that number I'm trying to hold up? 0. So it starts with 0, 1, 2, 3, 4, 5, 6, all the way to infinity in that pattern, right? You guys okay with that? What are the whole numbers and their opposites then? Okay, look at this number line. What's the first whole number? 0. And then you have 1, 2, 3, 4, and I can't draw them all. But what's the opposite of 1? What's the opposite of 3? What's the opposite of 100?
Negative 100.
Okay, here's a tough question. Ready? What's the opposite of 0?
Zero doesn't have one.
Zero.
Yes, yes, yes,
It's not a
yes.
number.
Yeah? No. Sorry.
0.
0 is a special number. It is its own opposite, or you could say it doesn't have an opposite. So it's a special number. It's its own opposite is how we'll remember it. It's its own opposite. It's special. It's that special. It's that cool. Okay, so guys, do you know the whole numbers? Do you know their opposites? Okay, so that's how you define integers, okay? Are there any other numbers, though? I mean, I said counting numbers and whole numbers and integers. We also have decimals and fractions. That's another category. So we have more categories. In fact, guys, we're dealing with the category of real numbers. If there's a category of real numbers, there must also be a category of...
Fake.
Yeah, I love it. Fake. Not fake. They call them imaginary numbers. Imaginary. We'll get to that later. Yeah, that's later. All right, so here's how I use set notation to describe all the integers. This is what I'm going to do. Okay, go ahead and write that down. These are all the integers, all of them. Like what? I thought I only have, 9 of them up there? But how many integers are there? How many integers? I heard a lot, and then I heard infinity. There's an infinite number of integers. It never ends. What do these ellipses, or these 3 periods next to each other, and then these 3 periods, they're called ellipses. What do they mean? What do you think they stand for? Elizabeth? Yeah. So do you guys see that it goes on forever in the positive direction, but then it also goes on forever in the negative direction because these are all the integers. This is set notation. You guys get that? Pretty clear? Okay, ready? Let's do a little review. Sydney, what's a natural number? Or what are the natural numbers?
They're like the positive numbers, like from like 0 to
Super close. Natural numbers, counting numbers. Start with the number.
like 1 through 10.
Yeah, and it goes 1 all the way to 10 and beyond. Because right, you can keep counting to a billion. Could you technically count to a billion? A billion 1, a billion 2, a billion 3. Okay, so you can keep counting. Those are the counting numbers. Okay, Timothy, what are the whole numbers? They're all the counting numbers and the number 0. Very good. Caroline, what are the integers?
All the whole numbers and their opposites.
Very good. All the whole numbers and their opposites, okay? So you see, we have 3 categories so far. Natural, wholes, integers. Okay, let's move on here. On example 1, do you guys see on page 67, do you see that number line there? And example 1 is I hope it's a very straightforward example. It gives you a number line, and it says, name the coordinates of D, E, and B. Okay, so D, where is that little point for D graphed? So what's the location of D? Emma Grace? Where's D located? On example 1. 4. So you just say D is 4. All right, the next one was E. Josie, where's E located? -3. So E is -3. And then the last one was B. And where is B located? Max?
It is +2.
+2. How many of you had a problem with that? Like you're like, wait, how'd they get these? I hope not, right? It's pretty like, yeah, it's right there, Mr. A. Good, good. Okay, you're going to be able to look at a number line and say, all right, what that little circle, that little dot, that little point represents is one of these numbers. Okay, B. B wants you to use, and I'll label this as B, for example, 1. B wants you to graph points F, U, and N, which spells what?
Fun.
You know why? Because math is?
Fun.
Oh, look at that. I didn't say it. I didn't say math was fun. I just said math is, and you fill in the blank, and you said fun. Congratulations. Yes, that is it. All right. Anyway, let's get the number line here, and somebody tell me what's F stand for in this problem? And B. F is going to be what? Yes, ma'am. +1. What's U? -3 and N. 4. +4. Now, when I do my number line, some of us are tempted to do this. You're going to go here. You're going to start here with -9, -8, -7, -6, -5, and you're going to go all the way to +9. Is that necessary? No. Why not? That's a lot of the integers, but why is it not necessary for our graph? John?
Because the highest and lowest number we're really facing are -3 and -4.
Okay, so maybe I'll go. So maybe I'll go -4, -3, -2, -1, and then what's the highest number? 3. Okay.
No, it's 4. Yeah, so you can go 5.
Okay. All right. So I don't have to do the whole number line. In fact, I can't do the whole number line. I want to do a piece of it, a segment of it, and that's actually a geometrical term. All right. Where does the first dot go for F? Where does it go, Sophie?
For F,
1. All right, this is what you have to do. You have your number line. Every one of you is able to do that. You put a point on +1, so it's clear that's a point. Don't just do that. You know, that's a point. You see it? No. That's a point. And then it was labeled as F. Okay? That's how I know that's point F on positive 1. You got to do it that way. Okay, and then what's U, Braden?
It is
Negative 3. So how do I put negative 3 here? Or how do I show that U is negative 3?
to a big giant dot.
Okay. Yeah, just make it clear and not overbearing on the grader. So that's U. And then N, the last one goes where, Callie?
Positive 4.
So how do I do that?
Dot and then big circle.
Big circle, shaded in. And then what letter was that?
And
N. What if I accidentally put N?
get it wrong.
What? That's just next to N. Okay, it wasn't N, and they asked you for N, and so it would be marked incorrect. Bum. Yeah. And then, yeah, that doesn't make sense. Bum. Anyway, you guys good on these? It's pretty straightforward. All right, last concept here. I love the number line for this next concept. Have you guys heard of the term absolute value? Oh.
No, I forgot. Yeah.
Okay, have you heard it? Even if you don't know what it is, you've heard it. Okay, absolute value. Absolute value uses these symbols, these absolute value signs. Oh, and here we go, Bella. The what was I gonna say? The Human Dictionary. Go ahead. What is absolute value? How about this? All right, how about this, guys? Draw another number line and go from, let's go from negative 5 to positive 5. Negative 5 to positive 5. Okay, hold it for just a moment, Bella. Go ahead and do your number line.
How many? Negative 5 to positive.
Yeah, negative 5 to positive 5. And just like with graphs on a coordinate plane, remember how we had evenly spaced tick marks? You want to do that as best you can here as well. And we're going to do that tomorrow. So I'm going to see if you guys really understand how to do this. But anyway, so you should have your number line. Bella, what is absolute value?
The number units a number is from 0.
Wow, what does that mean? Yeah, it seems like a lot. Okay, let's go ahead and look at it through example here. Okay, somebody give me a number on this number line. You can pick. You get to pick. Tristan?
3.
3. All right, so I'm going to put circle on 3. And I want to ask this question. What is the distance of 3 to 0? What's the distance from 3 to 0? So what's the distance from here to here? Michael?
3.
Yeah, and that's what they're using in the definition, 3 units. Or 3. You can say 3 or 3 units. Okay, give me a negative number on this number line. Josie? Negative 4. And so I'm going to put another dot on negative 4. What's the distance of negative 4 to 0? What's that distance from negative 4 to 0? Negative 4 to 0. Jensen? What do you think? 4. All right, so from here to here would be 4 units, or 4. All right, let me see here. Let's see if you guys are paying attention. Use your imagination here. What is the distance of 53 to 0? 53 to 0. Okay, guys, it's like way out here, like somewhere right here. So you got to imagine it. Oh, wait, Mr. You said 53. Yeah, 53 to 0. How far is that? Callie? What? How'd you know that? Yeah, because 0 all the way to 53 would be 53 of those spaces. We got that, right? Okay, how about this, smarty pants? What about the distance from 0 to negative 47?
I have B.
Negative 47. Okay, I said negative 47. Max?
47.
What?
What?
Did you guys get my answer key? How's this so easy?
Negative 47.
All right, how about this? Listen to me very carefully. In all of these answers, whether I've asked a positive distance or a negative distance, what has been the answer, positive or negative?
It's the same number you're asking.
And it's always been a positive number. Okay, ready, guys? That's the whole idea of absolute value. And here's our definition. So definition, the distance.
Is this the definition of
of absolute value. A distance, a number is from 0. That's all it is. That's the distance a number is from 0. That's all. That's it. Today it'll be pretty straightforward, I hope. It'll be like, oh, wow, what's the distance of 9 to 0? 9. What's the distance of negative 11 to 0? 11. That's okay. We'll all get it. So let me give you a few examples just to make sure you know how these problems are shown. Okay, so let's see here. What is the absolute value of positive 4? So this means absolute value of 4 is what? Jack?
Is it like 4?
It's just 4. All right? When you see these symbols with the number inside, you're asking what's the absolute value of that number, and it's just 4. Okay?
But it looks like 141.
Yeah, that's why I have to make these taller than my, like 141 would look like that, and then it'd be this, right? So those bars have to be taller than the numbers that you're writing. Okay, what's the absolute value of negative 3? What's the absolute value of negative 3? And they'll make it clear, by the way, guys. They're not going to try to trick you. Oh, that was 131. Or 1 minus 31. No, they won't do that. Caroline? It's positive 3. Okay? You guys okay with these? Let me give you a trick one. Ready? Super hard. Ready? The absolute value of 0.
0. 0 is the answer.
Michael? You sure? You're saying the distance of 0 to 0 is 0? Okay, because you are correct. Okay, that was too easy. I got to get my hardest one here. Ready? Here it is.
The answer is
I got to put my book down. Kind of loosen up here. Okay, wait until I ask you what the answer is. Okay, I'm going to write the beginning part and then I'll ask you at the very end. Okay, so don't say anything, please.
I know what it is.
I haven't written anything. Huh? Wait, sorry, did I put too many marks up there? Okay, Elizabeth, what do you think? Okay, you're telling me that the opposite of the absolute value of negative 15 is negative 15? Okay. Okay, ready, guys? Listen, if I just gave you this problem, the absolute value of negative 15, what would it have been? 15. But what am I asking for? What is the opposite of that value? It would be negative 15, okay? Don't worry too much about this, guys. You will see this later. I really want you to get these 3 down, okay? You'll see this later, and I hope you're not too scared of it. You should be, but don't be too scared right now. Okay. Look at example number 2. We're going to finish up here. Example 2. And we'll look at A. This one's the absolute value of 9 plus the absolute value of negative 9 is equal to blah. Okay, so the way I work this one out is I deal with the absolute values first. In fact, guys, remember PEMDAS? We never talked about absolute value signs. Where do you think it goes in the PEMDAS or PEMDAS sequence? All right, which one does it go in? It's got to go in one of them because we're doing it. Which one does it go into? I heard A.
Every one of them.
Every one of them. Okay, that's a nice way of putting it. Yeah. It goes in the parentheses.
Yeah, that's right.
It's a symbol of inclusion. You got to do what's in here first. And then you can start exponents and multiplying, dividing, adding, subtracting. All right, what's the absolute value of 9?
9.
Okay, plus what's the absolute value of negative 9?
9.
So what's 9 plus 9? Okay, so do you guys see that the absolute value of 9 plus the absolute value of negative 9 is equal to positive 18? I hope that's fairly clear. All right, and then B. B is the absolute value of 13 minus the absolute value of negative 2. All right, so first I deal with the absolute value signs. What's the absolute value of 13? 13. Minus, what's the absolute value of negative 2? 2. So it's 13. Ooh, that's a 2. 13 minus 2, which is what?
11.
Okay, that would be the simplification. Do you guys see that? Okay. Example 3. The only difference between this is you've already done these type of problems. Example number 3, though, is it saying what's the absolute value of x minus 7 if x equals negative 13? Excuse me, negative 13. So I'm looking at example number 3.
Well, it's exactly like, it's just,
Yeah, and here's the reason. Why don't they just make it like the other problems? I guess that's what you're asking. Well, because a lot of problems, you get these expressions from other problems that you worked out, and then you get what x equals, and then you can plug it back in. So it's good to be able to not only use the actual problem, but substituting it, which is what we're doing here. So watch carefully what I'm doing. I'm going to substitute x with,
13.
excuse me, negative 13. So that's what I have now, right? What's the absolute value of negative 13? Minus 7 is going to give me 6. There you go. You guys good on those? Good. You're going to prove it to me by doing numbers 18. Question?
What was number letter A
Example 2A is 18. All right. Tonight you're going to do 18 to 46. Please pick that up. 52 to 56. Pages 69 and 70. Get started. If it's a lot, get started. All right. I'm going to go ahead and